My name is Ivan Soroka. I'm a JavaScript developer at Supercharge right now. Currently, I have like up to almost 4 years of professional development in specifically JavaScript. And I specialize mostly on the Angular, but recently I'm also doing other stuff. And today I'd like to talk about new Angular's engine, which is called Ivy. And yeah, before you ask, it's not an official icon there. I just created it so that to make some difference, so that you can see where I'm pointing to Ivy and not. So I would like to begin with why Angular is working on a new engine and why is it required. So I'd like to highlight here 2 main reasons. So one is that in recent years we all know that mobile devices have conquered internet, and now most of the traffic coming from mobile devices, and therefore they may have bad connection and so on. So often we struggle to optimize for that. Sorry, goes to sleep. So and the second notable reason is Angular Elements, which is Angular's implementation for custom web components. And so Angular team, I don't know, yeah, it's coming back. Fine. So Angular team set some goals for themselves to achieve in order to improve the framework for those reasons. And I think the most notable one is the smaller bundle sizes, which are essential, especially for Angular Elements, because since we want to deliver those web components as lightweight as possible, we want to throw out a lot of stuff from the bundle. Second is lower memory footprints. This is maybe not that important, but still can be highlighted for mobile devices. Yeah, also for developers, it's also very important to have faster build times, and especially rebuild, because in development mode we change a lot of things all the time and we don't want to wait for eternity. Next is new possible features for future development, of course, because since we move on, we have new patterns coming and we want to keep up with the technology. And one more reason is simpler debugging, because what Angular current engine is generating is really hard to understand what's happening there, and also they are trying to make it possible so that you can just set breakpoint in the generated code and just go through it. I can say that it works perfectly right now, but we'll take a look at it later. So now I would like to highlight some differences between Vue engine, which is current engine of Angular, and Ivy. By the way, Ivy is since Angular 8. Oh my God, sorry. So since Angular 8, Ivy is already in opt-in. So it means that we can enable it and try it out. And it's planned that since Angular 9, it's going to be on by default, which is supposed to be actually next month, I believe. So hopefully soon it will be released. And so yeah, let's get to the differences. So first thing is that Vue engine creates these factory files during the compilation time. And we'll have a look at what it looks like later. And in Ivy they are doing it differently. So now they are just compiling everything from the decorators and from the class into static definition fields. I will show those later. Then Vue engine kind of generates something that is similar to Virtual DOM. I will explain it also in next slides, what happens there. While in Ivy they came up with something that they are calling incremental DOM. I mean, actually, it's not that they came up for it newly. As far as I know, they've been using it in Google internally for some time, actually. And one more notable thing is that if you engine create for the third-party modules that are being published to NPM, for example, it's creating like these metadata JSON files, which later require to be also considered during the compilation of your application. But we'll have a look at it later. And Ivy can ship the IoT compiled code directly to NPM, so we no longer need to compile that. These are the key differences. I don't know, actually, before I proceed, I'd like to ask, like, how many of you are actually familiar with Angular? Oh, quite many people, actually. That's good. Then let's move on. I'll just make sure that it doesn't. So, yeah, I'd like to talk what principles and ideas Google developers were following to make Ivy possible and to actually improve the framework. And first notable is locality principle, which basically means that when Ivy compiles the application, for each part of it, it should use only data from the class and its decorator, and should not rely on the data from its children, for example. So that when we change internal details of the children of some components, for example, then we don't need to recompile also the parent. So here I would like to show an example. So we see a really simple component here, which is just a root component, and it has a child. And in Ivy, it gets compiled into this. So what we see here is that now it creates a class. So this is actually readable, so we can understand what's happening here. And so Ivy creates a class, and then those two.
Sorry, we can't hear you if you talk this way from that way.
Okay. Yeah. So what's happening here is that it creates the two static fields, ngFactory def, and this is where you will get your dependencies later. I will show that. And the component def is what's coming from mostly from the decorator, and also the template is getting compiled into this template method, which contains the instructions. And I will talk more about that in part about incremental DOM. So, and now let's have a look what's happening in current view engine. So as I already mentioned, it creates this factory.js files, and each component requires global static analysis, because it compiles it in a way that sometimes when you change the internal details of the child components, it also may change the parent. And now I would like to show an actual example of it. I have a small application running here. So let me just quickly show you. So here is the I don't know if you see, I will just zoom it in.
Can you zoom in a bit?
Yeah, doing that.
Thanks.
Just searching for the right, okay. Okay. But here there is actually not much to see, because it's just a child component here.
Still want to see in the system preferences, please.
Zoom, wait, let me find the proper command. View zoom in, it's command and this. So it should work like this. Oh, it works. Okay. So, and this is what our child looks like. So now I would like to go to the browser, and I have it running here.
Ivan, please speak
So we see this lots of code compiled here, and it's really hard to follow what's happening here. And what I'd like to change now in this component is that I'll just go to the, so here is the compiled version of the parent. And I would like to go now to the code. And here, in the child, I have a service that I would like to inject. So let's just inject that service. Call it whatever, it doesn't matter. So we have this. So now let's save it and have a look at the same factory file here. So as you can see, this is app component. I don't know if you can see, but I'm going to zoom it in. So this is still app component factory.js. And what you can see, what happened here, is that now the service that I injected got also specified there. And this means that we already changed the parent by just changing one thing that seems like internal detail of the child component. And this is just one example, but there might more stuff happening, and that's why we compile more than we actually need to. I mean, especially when we are recompiling after some changes. So that's what locality principle is all about in Angular, to solve this problem. Yeah, and here I just put this code the same, and here I'm highlighting that the stuff that was injected also compiles into parent. So that's not cool. Now I would like to go back to my example and quickly change the application to run with Ivy. That can be done very easily. So no, not the right file. So we have tsconfig app.json. Yeah, should be in Angular compiler options. So we need to set one option here. It's a bit hard to type with one hand, so I'll put it down for now. Oh, yeah. Thanks. It's a bit hard doing live coding like this. And then here we say enable Ivy and set it to true. And one more thing that we need to change is we set AOT to true, because now we can run with that. No, that's not what I wanted to do. OK. So now let's restart the whole thing. Hopefully now it's going to run Ivy, because I might have done a mistake there. It looks like. OK, let's have a look. So. Now let's prettify this file. Yeah, now this certainly looks like Ivy to me. So let's remove that service from the children component. Let's just comment out this. Comment out this constructor and have a look at the app component code again. So this is what it looks like. And here we have the factory of the app component. At the moment, we don't inject anything, so it looks like really simple. And we have the template function. And this is where the child is created. So now let's uncomment this change. And after reload, we see that nothing changed here. That's because if we now move to child, so we can, oh no, I'm not searching in the right place. So my component, yeah, here is its code. So what we can see here is that, where is the factory? Def. Let's search for the factory. G. What?
There was a V missing from component.
Oh, thanks. Sorry for being slow here. This wasn't expected. Okay, off. So what I wanted to show here is that, so now the injection moved to its factory, actually. Ah, wait. Ah, I see. Yeah, it's in the constructor here. And so the detail of the service injection is now only here. And actually, the parent has nothing to do with that. Yeah, here the factory is. Yeah, sorry. Yeah, and you can see that now it uses this method, directive inject. This is IV method. As you can see, there are let me. No, this is too much. And close these. So now I hope you can see it better. There is this directive inject method. And currently it's marked as experimental API. So I believe it's going to be available in public as well. So we can use it not just as a compilation result, but it's also going to be something that can be used, which I will also mention a bit later. But yeah, this is how the stuff is getting injected now. So this is just one example of what changes so that we don't have to, during compilation, compile too many things. OK, now that I spent a bit too much time with this, I will move on. So let's go. And here I will. It disconnected. In just a sec. Yeah. Okay, it's working. So, and now I would like to talk about this AOT and template checking. You know, we all know about that famous situation on Friday evening. I mean, it actually happened in reality. I mean, sure, not on Friday, but I just wanted to make it more dramatic. So, you know. So you are just sitting and trying to solve a complex problem. And then an idea comes to your mind that you could actually do something really smart in Angular. And like, write a code like this, for example, when you wanted to, like, I don't know, get some configuration with the dependency injection. So you just write a factory like this, for example. I don't know if any of you know what's wrong with this. Actually, in more recent versions, Angular will hint it earlier, but 2 years ago, this was really a surprising problem for me. So let's move on. Actually, you run it and it compiles, so it works. And you test it and it really seems to work. So you are really happy because stuff is done. So that's a lifetime accomplishment. So you just, merge it to master because why not? And then you just go home because life is so good and you just want to rest. So then what happens when you come back is that you find yourself surprised because actually all the time CI was bombarding you with emails like, hey, actually it's not okay. I won't compile. And this is due because our ng-serve is running with GIT compiler, and the prod build is done with AOT. And there it does some extra optimizations and moves some of the things to compile time. And here specifically, it was saying that function expressions are not supported in the decorators. So tough life, you have to create an exported function for it, even though, in my opinion, it didn't make much sense. Even if you did it with a function and then created an exported provider for it, it would still not work unless you really make it an exported function. It was really interesting, but yeah, at that point I was like, yeah, thanks Angular. I'm really happy about this. So now let's take a look at how Ivy can change this. So since this locality principle that I just demonstrated to you, it makes compilation and rebuilding specifically a lot faster, we can use AOT by default. That's what I did when I switched to Ivy. And I will set a bigger timeout sometime. So since it compiles faster, we can use AOT by default. And that gives us such features like please. So we can get the template checking already during dev compilation. So now imagine code like this. So here we have template where we have a child component which actually doesn't have that sum prop, and we are still trying to use it. So actually GIT compiler would be totally fine with this, and it would never tell you that it doesn't exist and would run in development mode totally fine. But that's not how it should be actually, and that's where Ivy really helps. I mean, because it runs with AOT. So here we get a really useful error message that, hey, that doesn't exist. So I find it personally really useful. So problems like that one that I described with the example will not happen again, hopefully. Yeah. So now let's talk about the second principle that I would like to highlight about Ivy. This is an incremental DOM. So what happens differently here is that it creates instructions. So you just have a number of functions that are running one by one, and they directly do the DOM manipulation. So they are tree shakeable so they themselves are already like rendering engine, and therefore in itself it's tree shakeable. And so Angular generates this template function, which consists of two parts. And The first part is create, and the second part is for updates. So now it's a lot more readable than it used to be in View Engine. So we can even make sense of what's happening here. So we just have a P element with some text inside it, and then we have another P element that is wrapped in a template because it has an ngIf on it. And also each of these templates are like a separate classes somewhere in the main.js bundle. And then they also have their own template function, and it looks very similar. So that's still like separate view, but it's embedded here. And yeah, all of these are experimental at the moment, but as Ivy will be released, those will be removed, that some of these APIs will be available in public. So now let's have a look at how Angular is doing things now. And it's a sort of virtual DOM because so we have our HTML template, but when we so when we do some changes, what Angular is doing, it creates the template data objects. And these objects are something like virtual DOM, so that it contains information about what DOM should actually look like. And then there is interpreter in Angular, which then takes these objects and compares them and then applies the changes to the DOM. And so we have a nice diagram here that demonstrates what happens. So like we have the template, then it becomes a template data, and then it gets consumed by interpreter, and then it finally renders the DOM. So issue with this is that we don't know compile time which features of the renderer will be used, because we only interact with the template data. So we don't know what will be generated. And therefore, we always have to ship the whole Angular interpreter into the bundle. And since incremental DOM is just instructions, which are just functions, and for each DOM manipulation, there is a known function. And so as I showed already in the code, so you just have those like it creates element that does creates text and so on. And so it means that if we don't use certain features of the renderer, we can tree shake those functions, and therefore we don't get the whole thing in the bundle. So it means that we got rid of that interpreter there, and now we can get rid of some of the instructions that we don't use. For example, if you don't use content projection, you won't get it bundled and so on. So this is useful especially for the Angular elements, because we want them to be as small as possible. And also, the Angular team is trying to make it possible to also run Angular without Zone.js. So because we have to ship Zone.js together with the Angular elements, and that means that element itself may be like 10 kilobytes when compressed, and you ship another 10 kilobytes of Zone.js together with it. So what they're also trying to do there is that you would just run change detection manually with those functions that I showed. So there are also like detect changes and so on. So there is a reach API there. And let's move on. Also, as I mentioned, Virtual DOM creates these data objects about DOM with each render. And that means that we allocate memory, then after we done stuff with the objects, we don't need them anymore, so we need to get rid of them, and that means we spend some extra time garbage collecting, even though it's not that much. And these changes are usually very optimized. But incremental DOM, in this case, it only allocates memory when it really does the change. because we don't need to create an object in order to decide whether we need something or not. So it will allocate that this 6th element is added is only allocated memory for that when it really does the change. And therefore, it has the lower memory footprint. So now I would like to talk about what has been achieved so far by Angular. And I would like to talk about, first of all, bundle sizes. So I have a couple of examples here. So we have bundle size of Hello World application compiled with Vue engine. And here we can see this number of 207 kilobytes. This is already parsed. So it means that it's after tree shaking. And with Ivy in Angular 8, we get a slightly smaller amount, so like around 11 kilobytes saved. It's not a big amount at the moment, but as Angular team says, it's not completely ready yet. So tree shaking is not fully working there yet in Angular 8. But then I also got to try out the Angular 9, which is still not released, but you can play around with it actually. So there we got a decent reduction, even though it's still not what we would like to see, but it's already much better. So and now I would like to talk about large applications. So here we see an application that has a lot of lazy loaded modules. Yeah, that number is really huge, but it's actually not Angular's fault in this case, because that application has a bunch of other dependencies. And some of them pull other huge dependencies, so I won't talk about that. But here is the key is the difference between the bundles. So this is Vue engine, and it's like roughly 2.6 megabytes. But it's combination of all bundles together. Of course, you don't load all of that. So you only load like main bundle and then something, one of those, and common bundle and polyfills. But so yeah, let's move on. And here we have Angular 8, and we got the 2.3 megabytes. So it's like altogether we saved around 300 kilobytes. Not too much, but already something. And I was a bit surprised, but actually it's not that much a surprise to me, because in Angular 9, compared to how it improved situation for Hello World application, for the big application it doesn't change that much. I think that's due to a reason because in the real world application, it actually uses a lot of renderer features. So we don't, if we use them, then we don't throw them out. So of course it's still there. But perhaps they will still improve this further, since it's not even released. But where I really got to like Ivy, as I already mentioned, this compiles a lot faster. But you will be a little bit surprised now that so we compile Vue engine. We compile Angular up with Vue engine in like 22 seconds. But with Ivy, it compiled in 26 seconds. Like, what the fuck? And then in Angular 9, it's 23 seconds. So it's even more than Vue engine. And like, okay, why are we here? But if you have a look at these numbers when you compile a really big application, this actually makes a lot of difference. So it's just almost half the time for Ivy, which is really great. And I think we unlocked an achievement here. And so, yeah, also I'd like to mention that besides the locality principle being effective in the application itself, we also don't need to recompile the third-party modules code, because now we can either ship the whole JS done, or we have a new compiler for old modules, which is only run for the first build, and then you already have in your node modules compiled code for Ivy. So now what's next, just quickly. It roughly contains one slide because there is really not much to do about this. But I just would like to highlight the features that might be possible with Ivy in future. And so one thing that sounds interesting is lazy loading of individual components, for example. I believe that maybe we can even load like files. At the moment, the API is not ready for that, but we already use the dynamic JS imports, the native ones, for lazy loading of the modules. And another thing that Angular team is speculating a lot about is metaprogramming, so that we can do some fancy decorator stuff. At the moment, API is not ready for that, so I cannot show you around, and also it would take too much time. And another notable example is this new internationalization module that they are working on. Because I don't know how many of you worked with internationalization of Angular applications. The default one doesn't have an option for runtime translations. And it's supposed to be there, but it's probably not going to be in Angular 9 because that's still not ready. Yeah. Yeah, so I think I spoke about the most important things. I might have missed out on something, but you can still reach out to me and I can help. And I put some links here. That's what I was using for preparing for this presentation. And also the very first link is where you can check is Ivy ready. And I think it's stuck on 93% forever. Okay. So have you got any questions for me?
If you do, take it offline. We can do the questions afterwards. We run out of time.
Okay. So yeah, then thank you very much for your time, and I hope you enjoyed the presentation. And I put some links here so you can contact me and